Welcome to my project bazaar.com. Secure scan design against the scan based differential cryptanalysis. In our project mainly focus on the cryptography techniques. In our project the complexity and the interconnection in these areas would leave room for a different interpreters that can give rise to arguments. It seems positives that a rigorous definition based on some formal model could eliminate all margins of interpretation. However, in the case of the apprehension of the formal model itself can be questioned. Therefore, our definition of security is stated in the formal of manner. A security claim is not something that one should accept to be approved by the designer. The claim has two different functions. The potential cryptanalysis it serves as a challenge. Effective cryptanalysis consists of demonstrating weakness that refute the claim. If the function is which should public security through time by the absence of effective cryptanalysis, the claim serves as the specification of the security of the cyber for a system engineers and users who trust it. The cryptology activities is the giant effort of the designs, cryptogenetic primitives and analysis of their possibilities and limitation. The group of people that are involved in the activities is generally referred to the cryptology community. Important results are communicated in presence at scientific and technology conferences and these papers are presenting. Cryptography consists of encryption and decryption concept. Cryptography consists of two kind of keys, public and private key. This key type present here as security in our project. We pass it into the one input to the work factor of the generation of a single encryption symbol is the execution of the updating transformation and the output function. In specific implementation, practical construction typically impose an upper limit to this work factor. Hence, we can focus with the problem of dividing the available resource over the updating transformation and the output function. Turning a synchronous system cyber into a synchronous encryption scheme requires the specification of a initialization mapping. Preferably, this initialization mapping is as simple as possible, requiring a minimum of additional security in dedicated hardware implementation and a minimum amount of code in a software implementation. There is a strong difference between the effect of the output function and the updating transformation. Now, while on execution of the former only the affects a single encryption symbols, and the execution of the latter affects the evaluation of the internal state and thus the consecutive encryption symbols. As illustrated by the instructions works based on the mainly cryptography. These considerations have the different kind of things. Therefore, we use the cryptography analysis in this technique. We use a DES and EAS algorithm and a encrypt algorithm for the encryption and decryption technique. Here we are going to discuss about the system flow diagram. This system flow diagram represents the flow of our process. First, we give the input signal at image format. First of all, we give the encryption key based on the encryption concept. We get the cybertext. We get the cybertext, give it to the git additional data. Then next we transmit the data. Now we transmit the cybertext to our transmission well. Then next we receive the encrypted data. Then again extract the key from the cybertext values. We finally get the original image, and now finally we got the original images. Now we prevent the data hacking or intermediate nodes. The encryption key based on the two types. First type is public key and then second is private keys. Now we are going to discuss about the running procedure of our project. In our project we use MATLAB and Xilinx program. In our MATLAB program used for encryption decryption concept. Our Xilinx program used for the key generation purpose. First select main function.m and run. Select text encrypt, give the key and run. Please wait. Now we open our Xilinx program. Select simulation, select main function, then simulate behavior model. Set the clock value to 0, reset value set to 1, enable value set to 1. This is our reset condition output. Now change the reset value to 0, clock value change it to 1. Now we change the clock signals only, zeros and ones. Now we generate the different types of keys. This is our overview of simulation waveform. Now we generate the two different types of keys. Then again open a MATLAB function. Press any key. This is our encrypted output. Then again run the MATLAB function. Select text decrypt. Enter the send key. Please wait. Then again select simulation, select main function and select simulate behavior model and run that. Give the same condition, clock value set to 0 and reset value set to 1, enable value set to 0 and run. And then again change the clock value 1, reset value set to 0 and run that program. Please select enable value 1, then again change the clock value to 0, then again change the clock value set to 1, then again change the clock value 0. This is our randomized key. Please open our MATLAB function, enter any key. Now we get our original data. Now we complete our running procedure of our project. Thank you.